Hi, Jolene. How are you?
Oh, look at that.
Oh, noisy phone.
I'm good, Shelly. How are you?
Good. I don't know. Word didn't get out terribly well about our math circle, but I figured even if no one came, I was just going to do it and record it and see what happens. So,
Well, because I was going to say if you need to, if you need to not do it at all, I'm okay with that too. I've been wanting to be on this math circle every month, and something comes up every time, and so today was one of those days I could actually do it. So.
Well, I completely spaced the last one. No, my Google Calendar on my phone and computer haven't been talking to each other. So when I scheduled the math circle, I was like, oh, that works great. And then I noticed on my phone that I have a doctor's appointment for my daughter at 2. Like, oh, why aren't they on the same calendar? So
nice.
But we'll go till 1:45 and then it'll be good. Because I'm at the point of, I just want to do a math circle.
Yeah.
So anyway, let's see. Julie Greenman wants the link, so I'm going to do a quick text to her.
Okay.
And then we will change the slide and actually do something. But my goal for the math circle is for parents to experience what their children are experiencing in my math classes, number one. That's really the main point.
Mm-hmm.
And also to kind of become familiar with the math principles that guide the math classes that I've been teaching, since it's a little bit different it's a lot different from a public school, but it's different from what most people think of when they think of math. So Eileen's Jacoby's not in the classes, but that's
right. Well, and the reason I wanted to do the math circle is because my younger son, Braxton, that's just younger than Jacoby, has he loves numbers and he loves math, but I can tell that he's definitely in that still partly core love of learning area, but he loves hands-on stuff, and so I keep thinking maybe your math class might be what he needs if it could be more hands-on, doing stuff that actually, like he loves to be in the kitchen with me because it's hands-on. This is what we do. So I'm wondering. That's why I'm showing some interest, because I think it might be something that could work for him.
Good. I'm glad to hear that. I think so, because I will show some of the things we do, and it's the love of learning math. Randy can talk about it too. It's really hands-on. It's actually my favorite class, and I think everyone should do it that way, every age, but sometimes I have to sneak it in on them because it's so much fun they don't think they're doing math. So I always start my classes with a math warm-up, so you guys get to do the same thing too. This is from the pre-scholar class, so you can see how you tackle classes. But in order to solve this problem, we'll pretend my sticks there are matches. You need to move 2 matches. You can't break them, and you need to turn it into 6 without cutting them or breaking them. You can stew on this for a moment and turn on your math mind.
Turn it into 6 sticks?
6.
So repeat it one more time.
You need to move 2 matches in the pattern, so to change 3 into 6, but you can't cut or break the matches.
Oh, I got it.
I think I have it.
Go ahead, if you got it on paper, you can use that.
Well, I just turned it into that.
That's what our pre-scholar class did. They turned it into a star. What was yours, Jillian?
I moved 2 of them into a V so that it was the Roman numeral 6.
Oh, that was smart.
Very good. Actually, the solution in the book is to move them into a V and make the Roman numeral 6. And one of the reasons I love warm-ups is A, it gets our minds thinking, B, they're fun, and warm-ups like this help us to recognize that details really matter. So one of the things in the math classes that I enjoy is that sometimes we're explicit about that fact, but it really helps them pay attention to detail. It doesn't say 6 sticks. It says change 3 into 6. And as soon as you catch that, then you realize, oh, I could make a Roman numeral number 6. But otherwise, your brains all of us, our brains get stuck in a certain way of perceiving things. So one of the benefits of math is to break that and break free from that. And this is math. This is a riddle or a puzzle to solve, and it's not a worksheet. It's not 2 + 2, but it's math. So let me ask you, I have just 3 questions I want you to think about. What is math? Can you make math, and what is math for? I know I have a preposition at the end, but so as you have thoughts, feel free to just pop up with them. But I know it does take a minute to think about it.
As far as what is math, it seems like girls, I have a lot of things that pop into my head, and they're all, I think, right answers as far as math is thinking logically, and math is making calculations, and along those lines.
Okay. Comes to your mind, Jolene? What's math?
Well, I know this is going to sound maybe different, but I've always been really big on numbers. Like, even when I was in school myself, I loved math classes. But to go along with it, I love mystery novels. And I think it was because every time I had to use my logical brain to think about who can I take out of the equation and who is probably in the equation that has probably done it. So to me, that is math too. You know, reading some of these novels that I don't even know whether to call them classical books or not, but I love them, and it's been a long time since I've read one. But I think that that's math too, because it makes your brain really think and really itemize things and put them in places so that you can really.
So did you read all the Nancy Drew?
I did when I was young. I loved Nancy Drew.
Too.
I keep hoping Jacoby would get hooked on them, but she doesn't love that kind of stuff. So
I can't get any of my kids to read. I'm like, oh, that's fun. Math, what is math is a question that if you try asking your children, those who've been in my classes will probably give you a slightly different answer than they would have before, because we've really tackled this question. And we've tried to debunk the idea that math is those worksheets that you did in school, and help them to see that there's so much math in the world, and that math is patterns, and math is logic, and math is deduction, and math is solving, and math is creating an algorithm that will work. Math is computer programming, and that it's used in so many different ways. I like to ask the students how many branches of math there are, and they usually count up the classes they take in school. You know, well, there's algebra, and there's calculus, and then there's trig and geometry, and then maybe all the other stuff in elementary school, so 5. And there's, depending on which mathematician you talk to and how they categorize some of them, there's over 60 branches of math. And so we learn 5 in school if we get to calculus. But there's statistics, there's logic, there's deductive logic, there's symbolic math, there's a lot to math. There's knot theory and string theory, and a lot of it overlaps with the sciences, and a lot of it comes out of things. So this question in the middle, can you make math? Or do you just learn what's there, is a fascinating question. Can you make your own math? Yes or no?
I
see a thumbs up from Julie because she's driving.
I think the answer is definitely yes, but it scares me a little bit because it's branching off into the unknown, and if I say yes, then I might have to do it. but it's exciting, and as Jolene was talking about mystery novels being math, which I really like that idea. I was sitting here staring out the window at at nature, and then realizing and thinking about how much my kids have been talking about fractals and trees and nature, and seeing some of the other examples of the kids in the class that have pulled math that they find in nature. And so I think, as even in just a nature study, as you're outside and observing nature, you're making math, you're making discoveries and finding things, and I don't think it matters that somebody's found it before. If you're finding it for the first time yourself, then you're making math.
Mm-hmm. I like that. And I like that you're honest that it's a little bit scary, because I used to think that the value of teaching my children math was because it was the one thing that always had a right answer, and you followed the rules and you did it very detailed, and it taught a certain set of skills. And math can and does teach that when we're talking about calculations. But math is very creative and very freeing, and a little bit scary to branch out of that. And it's still really hard for me sometimes, even as I mentor the classes here at Monarch, because I feel like, it's the blind leading the blind. And my mentor tells me that's okay. And I'm like, but it doesn't feel okay. So you're kind of going down this with your kids. Like, I don't know what's going to happen. And yet when I say to my own children or my students, I don't know what's going to happen when we try this, let's just try it. And they actually believe you that you don't know. It's a wonderful, fun, creative experience. And I've learned through the last year of really tackling natural math that we have a lot of fears and phobias associated with math. But when we can break through those, it's like it breaks through a lot of other things in our academic learning and in our own self-confidence, that we can do not just hard things, but that there aren't as many restrictions on us and our thinking as we thought there were. That a lot of times we put them on ourselves and they don't exist. So this last question, we typically think math is for building or engineering or cooking, and we think of all the practical purposes of math, and it is for all those things. But somebody had to find the pattern that we then used to cook. Somebody had to find the pattern that we then used to make the medicine. And there are very creative people who just enjoy finding the patterns. It's the people who spent their lives perfecting origami, which on the one hand seems like a waste, who then took that skill and created ways to fold heart stents and ways to fold solar flares for rocket ships. And we give that second group a lot of praise and accolades of, oh, wow. But the kid who wants to be amazingly good at folding origami, we sometimes put that child down, or that skill, but it was the origami masters that taught the scientists. It wasn't the other way around. And so that's something I also teach my students, is that the creative people are doing a lot of math. Raise your hand if you like to either crochet, knit, cross stitch, or quilt. Okay, then you like math, because those are all forms of math. In particular, taking one string and turning it into a three-dimensional object is calculus. We love to tell kids they're doing calculus when they knit. Jocelyn quite likes that. Cross stitch is a form of calculus and integration, and you can actually talk to your children about the smaller you make the X's, and it's like pixelation in pictures. You can see that on the computer. If you like any kind of graphic design, you like math. You just don't realize that you're so dependent on math, because it's fun and it's creative and nobody made you do it. So there's my little, I still stink at math, but I've fallen in love with math. This is from naturalmath.com, and this is from Maria Drushkova, used with permission from her. Math is what you make of it, is right there in the middle. And these are her principles. So we try to live by these principles in our classes, and I encourage you to think about them in your home. So having a sense of, I have to move this over, openness means that you take change and share. Open math is like a recipe of folktale. You can remix it and you can play with your ideas. It doesn't have to always be the same. So if you cook a lot and you know how to make a white sauce or a bechamel sauce, then you know how to make cheese sauce, and you know how to make gravy, and you know how to make cream soup. And you can take that basic recipe and play around with it a lot once you've got the basic recipe down. And that's kind of the idea of openness. And then there's adventure. When we pretend to play and we do adventures in math, it should be fun. It should be an adventure. I don't know. Let's see what happens if we do that. Abundance is defined by her as feeling when you can choose or make the math that you like. And we have unlimited openness and abundant support. This is a big one. Often, I don't know why, because I do it too, but it's like math is the last domain of must make sure they understand before they leave home. It's really hard to peel my fingers off like one at a time from they will learn this. It will be okay. And letting them choose to do the math that they like. We all like different kinds of math. And we can gain a math mind from just studying geometry and never touching calculus or vice versa. It's okay. And then yes and is to improvise. And what I like about this one is Maria's taught me to quit saying no. There are no mistakes in math. You have to try something to find out if it works. And you might find out the part that doesn't work, which is exactly what gives you the solution to what does work. So she always says, oh, yes, let's try that and let's do this. And if she knows a child's going to do something wrong, she still lets them do it. And we say, yes, and let's try this too. Or yes, and what do you think will happen? And the mistakes are not mistakes. She encourages kids to make mistakes on purpose because then they realize that it's not so scary. It's okay. It fell over. It broke. It didn't work. That formula wasn't quite right. Whatever it is, but it takes away a lot of the fear. Her thing here for easy complexity is how she says 5-year-olds can learn calculus. And they really can. Yesterday in math with the little kids, we were talking about functions and inverse functions and functions that commute and things that we learn in algebra 2. They understood everything we were talking about because we were building function machines, and we talked about our function machines and can we put it in this order? What happens if we put it in that way? What's the inverse of your machine? And I used the words with them and they understood the concepts just fine. And when they come around to understanding functions, I hope they'll be like, oh, that's like that Lego thing I built in that class. That's all these are. You just put something in and something comes out and it's the same every time. And it will be so much more familiar to them. That's one of my biggest draws to this kind of math is when they want to advance to the complexity, they have the mathematical thinking to understand it. And then the last one is bridges, connecting and uniting different math ideas and principles. And I'm going to share an example from Randy's son Tanner here, but everything connects to stars for Tanner right now. And I think that's really cool that it all connects to stars. But we were talking about prime numbers and he was like, hey, that's why, yeah, of course they have to be prime. And he's building bridges between projects he's doing and different subjects. And it's connecting around this area that interests him right now, which is all these different ways that you can draw stars and composite stars and what we now call prime stars and things like that. And another great way to build bridges is, like Randy said, with nature study and things, math is everywhere. There's a reason that you have to take math for almost every major, because if you're in business, there's a math for that. If you're in chemistry, there's a math for that. If you're gonna be a doctor, there's a math for that. You know, it connects almost every subject together. And it's fun when we can build bridges between what we're learning and talking about. So are there any questions or any other thoughts on her principles here of math, natural math at home? Okay. This is some, I work on these regularly. I hope we do these in class, but I'm not claiming perfection by any means. So I can't, well, I could show this video, but I don't want to show a video and stream it because then it just slows everybody's internet down. So if you want to type the URL that you see on the screen into your browser and watch this 5-minute video. This is Vi Hart. Vi Hart talks really fast. I don't think you're supposed to actually understand what Vi Hart is doing. Randy's laughing because she's the one that introduced me to her. I think you're supposed to just be in awe of the patterns. If you actually want to understand the patterns, you have to like pause her videos 100 times because she just goes really fast. So the whole point of watching this is just for you to hopefully have that moment of, wow, I had no idea numbers did that. We showed this in our Scholar Math class this last 2 weeks ago. And so I just want you to experience that same feeling. I'll pause myself and watch, and then you can just give me a thumbs up when you're done with the video.
I tried putting it into the chat box for you, but I have something wrong on it, so don't follow that.
Oh, I can put it into. It's one thing I hate about the way my computer's set up. I can't just copy and paste a link into the chat box from here. It won't let me grab the text.
Pretend you're me and you're in math class.
Okay. I think we're done. Everyone's done? Okay. We'll go on after, but just, does anything in there make your mind go blah? Like the whole video? Okay, just checking. It is fun because this one we talked about number theory, and so we were saying this is what number theorists do. Yes, that seems silly. Let's make a triangle and put the numbers together and find the pattern and circle them and find out that it follows Sierpinski's triangle, and what is that? And you can find a lot of rabbit trails here with your kids just from this one video, and you could actually try to slow her down and see what she's doing and make the connections and realize, like her point when she says it's never about the numbers, it was about the pattern anyway. There are a lot of patterns you can play with, and then the kids can put numbers on top of it later, or even numbers on top of it right now as children, and understand that. So anyway, this is just fun. Vi Hart has a whole entire YouTube channel you can subscribe to and be blown away on a regular basis, but she always talks that fast too. And so when I show it to kids, I tell them, you're not supposed to understand anything she's saying. You're supposed to just watch the video and go, whoa, okay? And then they're usually more comfortable with the videos. So if you tell your kids the same thing, that can help. So I wanted to quickly, I'm checking my time, do a simple activity from each of my 3 levels of classes. So I did this with the Love of Learning kids. We made function machines. Who remembers what a function is from your days in algebra? Anybody? Randy does. So what's a function, Randy?
Now I have to explain it. I would say isn't it kind of like a rule where when you, well, it's going to sound like the machine, but I'm remembering last year helping Tanner with his functions. And so it helps you find another thing. So you put it through that function and then it gives you another number.
Yes, essentially. But let me put it in the way I taught it to the kids, okay? So see my machine, when I put in circles, out comes squares. Every time I put in a circle, out comes a square. And a function, no matter what your input is, it's going to convert it the same way. So we played a game. So you guys give me a number, and I will put it through my function machine and tell you what comes out of the function machine, and then you can figure out what my machine does. So just give me a random number. So Julie's saying 4, so out comes 8. You're going to have to do more than 1, or you'll never know the pattern. Hannah says 5, out comes 10, Hannah. Carly puts in 3 and out comes 6.
So the pattern is just double it every time.
Yes, my function machine doubles. That's right. And so how I wish that my high school teacher had taught it to me this way. He did try, I admit, but a function, if you're doing math, so whenever I put in X, 2, 3, 4, 5, 10, then what comes out is 2X. I doubled it. That's all those nasty functions are in math. And then the kids built function machines, and some of the machines, whatever you put in came out black. And then one of them, whatever you put in came out twice as big. So we were putting in a lot of ice cream and yummy treats yesterday in math, so it would come out twice as big. Jocelyn's took pictures and they came out 3D. And it seems like, oh, that's just fun. You built a cute thing out of a cardboard box. But 3D printers are taking something flat and making 3D. They're functions. And they use these same kinds of principles to build. And doubling, that happens a lot. And doubling the size and working at scale. So fun activities like this can be really helpful with your children. And you can play the game of function machine with them if you're wanting to do a little bit more math thinking with your children, but they're like number phobic. Then you can say, okay, give me a word and I'm going to give you, tell you what comes out of my machine. And maybe it's a rhyming machine. Or if they're really little, you can say, give me an animal. And every time they give you an animal, you give them where the animal lives. And those are functions and it helps them. Then what we did in class was we said, well, what's the inverse of our function machine? If you put in an inverse machine, then if I put in 10, I get 5 out. It does the opposite. And the kids were able to understand that just fine. What happens if I put it in the other end of your machine? Well, if it goes in black, it comes out its original color, or it will get cut in half because I doubled the size when it went in the other direction. And that's complicated math thinking. It really is. But they were able to do it so quickly in this fun format. And you can do this with your kids. You can do this with any age. And then we talked about having them commute. So we took one of our function machines would change your color to the opposite, and the other function machine would it would stamp out a paper mustache. You put paper in and out came a mustache. And that was the only set we found that would commute, meaning you could use them in both directions, because it didn't matter if you put the paper in and changed the color and then cut out the mustache, or if you cut out the mustache on green paper and then we put it through and it came out red. No matter what, you were going to end up with the same color mustache. And that was really fun. They were kind of in awe. Oh, wow. Because all the rest of our machines didn't commute. We couldn't do them in opposite orders. You had to go through in one direction. So they were learning some really important math thinking abilities. And it was very easy and really fun. So this comes from the book Mobius Noodles. And if you want to just play around with math, it's the best $9 you'll ever spend. And don't do what I did. I read it and I thought, this is just for really little kids. This is one of the ideas in the book. And this can be used with your entire family. And it can be just a verbal game of, okay, you make up the function, Tanner, and maybe it's, okay, the thing, it adds 10 and then it divides by 2. It can be a really complicated formula to come up with. When you're on a long drive, you can make up function machines and your kids can try to see the pattern of the math. And they're going to be doing mental math, and they have to make it up, and they have to be consistent, they have to learn the pattern, and they have to come up with an algorithm that works. And I could talk about spreadsheets too with that, but I don't have time. So we'll save that for another time. This is from the pre-scholars class. So we talk a lot about logic in the pre-scholar class. That's what a lot of our classes have been on, in finding the truth of mathematical statements. And this one, you don't have to have a whole lot of background knowledge. So I picked this problem, but they did this as homework. You have Bim, who always tells the truth, and Bom, who always lies. Those are a given. They always tell the truth and they always lie. What question should you ask each of them if you want to get the same answer, assuming that you don't know which one tells the truth and which one lies? So can you come up with a question you could ask them and get the same answer out of them? You can type in the chat box or raise your hand. Hannah will probably come up with it before all of us, won't you, Hannah? Hannah's good at this kind of math.
You would ask them both what not, and then the honest one would say what it is. And that would give you the answer, and then the one that was lying would say what it is, because he was trying to tell you. He was trying to lie to you because you thought that it was the...
So give me an actual question that follows your example. Okay, come up with one. And no asking your pre-scholars that already have the class. We won't take forever.
She's not even supposed to be in this class.
That's all right. She was in the car with you. Any ideas what you can ask? They both have to give you the exact same answer, but one always lies and one always tells the truth. These kinds of questions you'll find all over the internet. They're just logic riddles. Logic riddles are really good for developing deductive thinking, paying attention to details, stretching your brain. They make my brain hurt after I do too many of them with the classes.
So couldn't you just ask them if they tell the truth or not? And if I asked Bim if he tells the truth, he'll say yes. And if I ask Bom if he tells the truth, he'll say yes as well. Very good.
There's more than one answer to this question, which I always like. The value lies in in the negation of bomb and thinking through, okay, what will they say? What could they say? What are the possibilities? Will that force them to both say yes? The really easy one that our students did was, we'll just ask them, are you Bim? And Bim will always say yes, and Bomb will always say yes, because Bomb's lying. So questions like that. We played a lot with Knights and Liars Island, and it helped the kids learn to do what are called truth tables, which we do, which is that's another field of math, is logic, deductive logic, and then truth tables. But even if they aren't in logic, and that's not their favorite thing, any kind of proof, geometry, if you struggled with geometry proofs, and most people do, it's probably because the deductive logic that's required to set those up, if this, then that, then if this, then that, was weak. And so playing around with riddles and logic puzzles like this really strengthens your kids and prepares them for geometry. And it's also just a field in and of itself. I took a class on deductive logic in college because I didn't want to take algebra again. So I got my math credit that way. And it was really fun. Really hard, but it also helps in your writing because it helps you to form a logical argument that's sound. So I see a lot of value there too. Last one, really fast. This is what we do at the scholar level. We do things like studying primes and number theory and negative numbers, and they tackle some really tough challenges, but I gave you an easier one. So has anyone ever heard of I always say it wrong, Eratosthenes sieve? This guy.
It's called Eratosthenes.
Eratosthenes. I'm not good at Greek.
Eratosthenes.
Do you know what a sieve is?
Yeah.
What is it?
Well, it's you put the number. It seems, if I can remember, if I can explain it right, he puts his number through this, and is it the prime numbers that fall through or something that turn colors? I've watched the video many times, but I can't explain it actually.
It's all right. With our students, we did a worksheet. So this link, if you want to snag this link, is a worksheet that we did. Remember, they didn't have calculators and computers to do all of the work for them that were programmed. So he had to find the prime numbers, and he was trying to find all the prime numbers without sitting there. Well, what is 1054 prime? Is 1053 prime? When you get to big numbers, there's things that are divisible by 19 and weird numbers you never learned in math to memorize. And so it gets trickier. And without a calculator, he was trying to figure out how to find the primes. So you can find all the prime numbers up to 100 by listing them. You don't even have to have a worksheet. You list 1 through 100. 1's not prime. There's debate over that, but 1's not prime. 2 is prime. Happens to be the only even number that's prime. Why would that be? You do know what prime is, right? Okay, just checking. 2 is the only even number that's prime. And it's the only even number that can be prime. Because you're thinking. Why can't any other even numbers be prime?
Because all the other even numbers are divisible by 2.
Very good. By definition, an even number is divisible by 2. So 2 is the only prime that's even. So then 3 is prime. So as you write them down, you circle 2 and you circle 3. And then when you get to 4, that one is not prime because it's got 2 and 1, or as it's 2, 1, and 4 as its factors, but you're just doing the 2. So you cross out the 4. And then when you get to 5, you circle that. When you get to 6, you cross that one out. And it's just a piece of paper. He calls it a sieve because the prime numbers are the ones that will come out of the process, like Julie said. And it's the way they did these tougher calculations. And you could actually start at the top. You could start at, like, if you're trying to do 1059, you could start at 1059 and you could try to find all of the factors. And we were learning about that as well. And you can use the sieve. And I'm running out of time, or I'd have you give it a try. It's actually pretty easy. And this link here, you can find one. You can find a lot of information about it online. You can watch videos or see how it was discovered or why he came up with it. But prime numbers have been something that we have been studying for a long, long time. And like Vi Hart kind of made fun of him, but number theorists quite like that. And number theory is a branch of math where we spend a lot of time talking about why do numbers behave like they do? And they ask questions that seem really silly, but why do these numbers add up? And why does it work this way? And they have very philosophical discussions of, are we discovering principles that exist, or are we making up patterns and laying them over these principles? And the more I've studied math, the more I've come to appreciate that it is an extremely diverse, creative, philosophical, practical. It doesn't matter if you're really pragmatic or really creative and artsy, there's a spot in math for you. And you're probably already using it, you just don't realize it. So that kind of my introduction to a variety of different types of math, different levels that we work at Monarch, and kind of what we do. We push them pretty hard. My last suggestion for those of you that have not read it is to read A Beginner's Guide to Constructing the Universe. If you need to break free of math the way you learned it in school, then read this book and see the beauty of math everywhere, in religion, in politics, in art, in nature, in science, in the rock crystals around you. This book will open you up to, whoa, that's math more than anything that you could start with. So that's why I threw a slide in there. I have like 1 minute if there's any questions. Otherwise, you're welcome to email me and ask questions about my classes or whatever else. Don't ask me a lot of math questions. I'll just tell you what I tell students. I don't know. So anyway, any questions or thoughts? You're all good to go. I talked a lot more than I do in the other classes. I make the students work harder. Talk to your kids about the classes if they're in them, or check out the dinner discussions for math, even if your kids are not in the math classes, and use the benefit of the internet to check out what is a fractal and check a Vi Hart video and try a few of these things and play around a little bit. It really does become really fun. It's just hard to find time to do it. At least that's what I found. So thank you for being here. Appreciate it.
Thank you.
Bye, Randy. Off to the doctor with